Okay, so last time we did phase and phase difference. I said that phase difference means that basically it is the difference of the angle in terms of position, of two different points, right? Now, I just want to remind you before we go forward that if the phase that you see is either 450, is if it's 0, 360, 720, then it's basically called in phase, which means both points are in the same sort of movement, they have same direction, same velocity, same displacement. If they have a phase difference of 180 degrees and the multiples of it, then you guys need to understand that these points will be anti-phase to each other, which means they will exactly be opposite in all terms. Like opposite velocity they'll have opposite direction and opposite displacement as well. But then any other angle than these two, which means 0, 360 or 80, any angle other than these, you will see that they're out of phase, which means they will be different, but not exactly same, not exactly opposite. So you guys need to remember this. Anyway, so if you have any questions about it from the last lecture, do let me know. Otherwise, I'll just wanna go forward. Okay. So now the next. So suppose that, by the way, it has never came in the exam, but you cannot also rule this out. So I just wanna tell you about angle in radians. There's another way of taking angles, but then it's a gray area in the syllabus. You guys need to remember the conversion of this. Like 180 degree is equal to pi radian. This is the value of this angle. So if you change this to any other angle, for example, if you want to have 360 degrees, it will be like 2 pi radians, 90 degrees will be like pi by 2 radians, and so on. So you can basically change anything with this. You can cross multiply, you get the value in radians. So it's not just not a big deal. It's just a small thing that you need to remember. Is it clear? Any questions here?
Yes.
Now, so okay. Yes, Dania, you can hear me now?
Yes.
Okay, that's fine then. Okay, so now we're gonna look at one of these type of questions. For example, right here, it says a wave is leading, a wave is leading by a phase. Oh, by the way, wait a second. Sorry about that. I just needed to just a second. I'm sorry. I'm sorry. Abdullah, can you hear me now? Abdullah, you guys can hear me? Is there a problem with everybody?
Yes.
Yes, sir, I can hear you.
Okay. I don't know why this is happening. Anyway, so then a wave is leading by a phase difference of 45 degrees from the wave shown. Sketch the wave. Okay, so this is the question. I'm just gonna make it black. They've already shown you a wave which sort of shows you something like this. Time in milliseconds. Here you have displacement in meters. The wave is already shown. And it's basically 20 and then 40 and then 60, 80, it's 100 and a 20, 120, 120, like that. Now the issue with this is that actually they say that you have to show a phase difference, the like two waves of phase difference is 45 degrees. But then this wave is shown in time. So what can we do about that? We'll basically try to convert it. If you remember, I said that 360 degrees is equivalent to a lambda and it is also equivalent to a time period. You guys remember that?
Yes.
What do you think is the time period in this?
80.
80, right? So 80 milliseconds is the time period. So I can say that 360 degrees then is equivalent to 80 milliseconds because that represents the time period of this. Understood? Now, what do we need to do? We need to draw a wave which is 45 degrees ahead of this. So what will be the difference if we want to basically create a wave of 45 degrees forward? So I'm going to cross multiply like that. And it's going to be 80 times 45 divided by 360. What would be the answer then? Yes, kids?
10.
So it's dead.
Sorry?
It's dead.
It's 10 milliseconds. It means the new wave will be 10 milliseconds ahead of this wave. So what does that mean? That this point, when it is at 0, it will be at 10, right? So every point of this wave is going to shift by 10 milliseconds. So 20 will go to 30, 40 will go to 50, and 60 will go to 70, right? And 80 will go to 90, 100 will go to a 10, and 120 to 130. Right. Hello, Raza, how are you?
Thank you, sir.
Right, so Raza, we've just started waves, so can you just go through, then at the end I'll tell you what to do, okay? All right.
Come again,
So
sir?
I said we've just started progressive waves, so just sit and see, and then at the end I'll talk to you what to do.
Thank you.
Okay.
Thank you, sir.
So because the wave is leading by 10 milliseconds, so if the wave is going to look like this actually, like that. Now why? The thing is that every point, like in the start, if this just started, this point will be ahead. This point, which was right here at 20, now it will be 30. So every point it has shifted ahead of the previous wave. Do you guys understand what I just done?
Yes.
And you can see what on the diagram, it seems like two waves are moving, but then one is ahead of the other one with the same amount, 45 degrees, which we can relate to time period or wavelength when we want. So then we can say, we just write here a note that each point of new wave is 10 milliseconds or 45 degrees ahead from the previous wave, like that. Okay. If you guys have any questions, you let me know, okay? Imal, Dania, everything is clear? Farina?
Yes.
Fine. Okay. Okay. All right. Should I go forward now? You guys have written this.
Yes.
Okay. Abdullah, you can hear me fine now, right? All right, Abdullah. So now we're gonna basically look at some of the properties of waves. Now, generally, we see these properties on a wave, on a ripple tank. Ripple tank is not in our course directly. You won't be asked about the ripple tank or anything. I just want to basically show you how it looks. Other than the, you don't really need to, do anything about that. Wait a second, please. So basically, a ripple tank looks like this. And the purpose of ripple tank is to demonstrate different behaviors of waves. All right. The most important thing in this one is that when waves are created in the ripple tank, basically dark and white lines appear at the bottom, and these dark and white lines are called the wave fronts. Now, the definition of wave fronts are included in our course, so we're going to write it here. So wavefront is basically a line connecting crests moving in a moving in phase. All right, like that. There are a couple of things that you guys need to remember. First of all, if you see a wave like this is a single wave, and another wave, like waves are generated many waves generate together. So all of these basically are the crests of the wave. These are also crests of the wave. So if you combine them or connect them with this single line, they will basically give you the wave fronts. So actually, these are the wave fronts, and the direction of the wave is like this. This is the direction of the wave. Now, the most important thing here is that the direction of wave will always be 90 degree to the wave fronts. And between two successive wave fronts, one wave front to the next, you can find the wavelength of the time period if you want to. Okay. So, I just want to basically tell you this important point right here, that direction of wave travel is 90 degrees to wave fronts. Remember that. The next point is the distance between two successive wave fronts is wavelength. Write these 2 points, all right? If you have any questions, do let me know. Okay, Asma, everything is clear. Furqan, Raza, Shazib. Raza, are you there? And Karina, what about you? Everything is clear? Please write this down. Okay. Okay, good, Raza. Now, basically, the first thing, in fact, I just want to tell you about the circular wavefronts, and then we're going to go forward. There are a couple of things, very small things that we're going to see. First, we're going to look at circular wavefronts. Then we're going to look at reflection. Sorry. In fact, let's do it later. No worries. So circular wavefronts are like, if a wave is originated from one single point, then what happens is that waves go in all directions, like these. And when they do, so what happens is that the waves are going like this. So it's sort of a behavior like this. Okay, they're going in all directions, but like this. So actually, it's the same thing. Basically, the crests are now here, here, and these crests are together in phase. So that's why when you connect these, they make a circle. So these are also the crests. and these are also the crests. So you can connect them and individual, every crest, the crests which are in phase, they just join together to make a circular wavefront like that. Okay. The other thing would be the reflection of a wave. So, reflection of a wave is carried out by two major laws. The first law, now I'm gonna give you the laws basically. These laws cannot be broken. The first law is that the angle of incidence, you've also done this in IG, I, will always be equal to the angle of reflection R. The other law for this is that the incident wave and reflected wave are always in the same plane, which means if they were both in the x plane, they would stay in x plane. If they were in y plane, they would stay in y plane. If they were in z plane, they would stay in that plane. Or else you cannot change that. I'm going to explain that in a bit. So if there is a sort of a barrier that you see, and the waves are coming in like that, and they strike at some point. So obviously, you might remember you had to draw normal like this. This will be angle I, and then the wave would reflect at the same angle from normal. This would be angle R, the same value. Does blue seem like it? Let me fix it. It doesn't catch it. So, okay. R. Okay. So the wave fronts would be like this, perpendicular to the wave, perpendicular to the wave, like that. So they get reflected like this. So you can write this down, please, and do let me know if you are confused about that. Anything that I've written here. Basically, the thing that I've written about the plane, it means that plane means, let's suppose this is the x plane. So it means that we're lying on the x-axis. And then a vertical plane may look like this. So if a wave is, hitting in the x plane, so it will basically come back in the same plane as reflected one. It will not go to the other plane. It cannot happen like that. So this is what the second point refers to. All right. Now the next is the refraction. Now for refraction, it's very simple. It's basically the bending of wave due to change in speed when it enters a new medium. You don't need to draw the diagrams, you don't need to know anything except for this, so don't worry. Just need to remember a few things. It's just, like you might remember that there were like questions about, so if a wave basically enters from deep to shallow, the only difference would be that it would go straight. You would want to make a normal line. This would be the angle of incidence, and then it would bend like that towards the normals. This will be R. The wavefronts were drawn like these. Wait a second. And then when the wave would enter into shallow region, the wave would bend like this. So if you remember from IG, we used to do that. So this is sort of that thing, but no worries. The third property, you can draw this, is diffraction. And we have a whole chapter on this that we're going to do later. So these are main three properties that we needed to remember. So you write this down and then we'll go to the AS thing that we need.
Sir, we won't have to draw anything, right?
No, no,
Including.
nothing. Literally nothing.
Okay.
I'm just teaching you because in the MCQ, if they give you a word like this, what is refraction, what is maybe they're choosing something, you should know what it does, right? But you don't have to draw anything, you don't have to know anything. This is just the phenomena that you need to know. Get it? Like that.
Yes.
But for diffraction, yes, you need to know everything, and we are going to do that later. It's not a big deal. Okay. So, should I go now? Forward, please.
Yes.
All right. So now the most important thing that we're going to learn today is the property of a wave that is called intensity of a wave. Now, a lot of questions from these would come in your exam, and you got to be prepared for that. So let's have a look. So intensity is basically defined as the power transmitted per unit area by an incident wave. So this is the definition. The symbol that we're going to use for intensity is I, and the SI units of intensity would be watts per meter square. The formula for this is I equals to power over area, where this is obviously intensity. Do not forget about that. This is power and this is area. Sometimes they might also give you a different formula. Do not be alarmed by that. It is written as I equals E over TA. All right, so this formula is the same formula as the first one. What they've done is in this one, this is intensity, this is energy, this is time, and this is area. Basically, it's nothing but they have substituted power equals to energy over time in this formula to get that. That's all. You can please write this down and let me know if you have a question. All right. Asma, everything's clear. Furqan, Dania, Iman, Farina, Raza.
Yes.
Yes.
Okay. Abdullah, everything is clear. Bache, any questions you have? Okay, very good. Written this. Should I go forward now?
Yes.
Okay, very nice. Now I just want to tell you that this is like out of like 10 questions, only one question might come out of this formula. The real questions of intensity will come with its relationships with three different things. So we're going to discuss that. First, the first relationship of intensity is with amplitude, and it's basically intensity is proportional to the amplitude of a wave whole squared, like that. The second relationship of intensity is also proportional to the frequency whole squared. And the third relationship of intensity is basically intensity is inversely proportional to the distance whole squared, which means that if the amplitude increases by 2, the intensity would increase by 4 times. If the frequency increases by 2, the intensity is going to increase by 4 times. And if the distance increases by 2, then intensity reduces by 4 times because there is an inverse relationship.
So this is
And I'm going to draw that a bit. What I'm saying is, suppose you have a wave like this, right? Like that. And let me just copy this. I've been using this so many times. Okay, so if there is a wave that is shown like this initially, right? And we say it has an amplitude of A and intensity of I, then when the amplitude is gonna become twice of this, the amplitude, even though frequency is the same, if the amplitude becomes 2a, then because of the function, like amplitude square is proportional to intensity. So you put 2a in this, when you square this, it will become 4 times. So it means the intensity will be 4 times of that. Is it clear?
Yes.
Now, generally, when there will be difficult ratios, we don't want to get into those ratios. Raza, I'm going to explain that in a bit, okay? Basically, what happens is that these ratio things they get very difficult once you have those ratios of root, and sometimes they will give you 1 by 3, 1 by 16, or whatever. So what you do is you just remember this one formula. You say if you want to find the intensity of a wave, the first wave, you divide it with the intensity of the second wave, it will be equal to amplitude square of the first wave over amplitude square of the second wave. If you just remember this ratio, you will be able to find any answer that there is. Let me just explain the same thing, the same phenomena that I've drawn using this method. Let me just move it here. Okay. Now see this. Brother, let's see. You see, the first wave that I drew had an intensity I, so I'm going to write I. I want to find the intensity of the second wave. The first wave has an amplitude A, so I'm going to square it, and the second wave has an amplitude of 2A, so I'm going to square that. Is it clear?
Yes.
Now, if I open this up, it's going to be intensity 2. It's going to be A square over 4A square, because 2 square 2 is 2, 2A square is also A square. So A square and A square cancels out. What you get actually intensity over the second wave intensity by 1 by 4. So intensity 2 can be taken there, 4 here, so it will be 4 times I. That's how you can do this. So if you increase the wave amplitude by 2, intensity is going to increase by 4. All right, Raza, do you understand this? Shazib,
Yes, sir.
just remember this formula. Just remember this formula. All your problems will be solved. Okay, like that. Now, same goes for frequency actually. You can copy this quickly and then I'm going to go to the frequency. With like 7 minutes left. Okay. Now, from the frequency perspective, I'm going to put the waves here. Let's look at here. And then same goes for here. So if you see a wave, let's suppose like this. Like that. And I say the frequency of this wave is F and the intensity is I. What would be the intensity of a wave that has frequency double of this? Like now the frequency is 2F. So now because it's a function of square, if frequency doubles, then intensity will be 4 times. Do you guys understand that?
Yes.
If the frequency becomes 3 times, the intensity is going to be increased by 9 times. So it's like every time a number increases, you have to square that. That will be the increase in intensity. So to basically remember this, it's very simple as well. All you need to do is you need to learn this formula. The intensity of the first wave, intensity of the second wave will be equal to frequency of the first wave whole square divided by frequency of the second wave whole squared, like that. And this will give you the intensity without even taking ratios. It's so simple like that. Okay? You guys get it?
Yes.
Yeah. The last one is an inverse ratio. So I'm going to show you what it does. So suppose that if, in fact, I'm going to show you this by a diagram. So suppose that there is a source of light right here. This source of light is sending light like this, okay, like that, from a single point. Suppose if I'm looking at a distance x from the source of light to this point, and I say the intensity here is I that we receive, then if I go to a distance from the same point, I go double the distance of that, then what happens is that intensity is going to reduce by a quarter because there's a square on top, right? So how do I know this? Because the equation for this one, so here intensity will be 1/4. So if the distance doubles, intensity becomes a quarter. If the distance basically triples, then intensity becomes 1/9. And I can simply find it using intensity of the first wave or intensity of the second wave. I can write that. Will be now equal to distance of the second wave whole square over distance of the first wave whole square. Now, what you need to remember is that it's basically like if you see the difference between the first two formulas and this one, and this is basically better to remember, because if you see here, intensity of the first wave is equal to amplitude of the first wave. So both of the things of the first wave are in the front or at the top. Same goes here, first wave, but here, because of inverse ratio, so intensity of the first wave is being equated with the distance of the second wave because they're inversely proportional. That's why. Do you understand that?
Yes.
Yeah. All right. If you still feel any difficulty, do let me know. Furqan, Asma, everything is clear. Dania.
No, sir.
Okay. Yeah, this is the way to solve any question in the world. It's so simple, like that. It's so simple. And I'll show you a question that you will be like, wow, this was this easy. Like, you don't even have to do anything if you remember these three things. And these formulas, I've just made it myself. Generally, people use a lot of ratios, and it's just too hectic to do them. Okay. Yeah, yeah, Rudra. I'll just show you a question now. Okay. Now, speaking of a question, let's take one out from the exam papers while you basically copy this down. So, where are you, progressive waves? Okay, they're here. Okay, so for example, let's have a look at this question, and then we're going to do so many more later, because wave is one of the most important topics that we have in AS, and it will have a short question on this. So let's look at a question quickly, and I think you guys will be able to solve this yourself if I give it to you. Okay. Now, in this question, it says a wave of amplitude has an intensity of this. So we can write the things. The first intensity is 3.0 watts per meter square. What is the intensity of a wave and an amplitude? Sorry, A1 they have given as A. They say what is the intensity of wave of the same frequency? So we have the same frequency, so we don't want to get into that. That has an amplitude of 2A. Now A2 is 2A. What would be the intensity if that intensity 2 if that is that? Do you guys understand that? Can somebody please tell me the formula for that relates amplitude and intensity, please?
I1 over I2 equals to A squared over A2, 2A squared.
A1 squared over A2 squared,
A2
right?
squared.
Now simply add this information into this. You don't have to think about anything else. I1 is 3, I2 is I2, A1 is A whole square, and A2 is 2A whole square. Now just solve this. You see, it's going to be 3.0 I2. This is going to be A squared. This will be 4A squared. A squared and A squared will cancel out. You're left with then 3.0 I2 equals to 1 over 4. So I2 will be equal to 4 times 3.0, and that's going to be 12.0 watts per meter squared. And here's your answer. Do you get it? You don't even have to do anything to
Yes.
solve this. It's so simple like that. Okay, Raza, is this clear to you now?
Yes, sir, it's clear.
So we're going to then tomorrow we'll see different variations of these sort of questions. This is the most this is type 1 question they're going to see most often, and see few variations. You'll understand what to do even if they include frequency and amplitude together and so on and so on. All right. So then have a nice day.
Thank you,
I'll see
sir.
you at the same time then. Bye.
Thank you, Salah.
Thank you. Ola.